Some science experiments, folks. We got them all set up over here on the right-hand side. Let's just watch what happens if I just put acid or base into this flask on the right. I'm adding hydrochloric acid. It's the same acid that's found in your stomach. It's just what I use is like 100 to 1,000 times more concentrated. Look at those beautiful color shifts. Aren't they pretty? Yes, they are. So you're seeing the color shifts because in this flask, there's an acid-base indicator called universal or rainbow indicator. Hey, Gigabean. Hello, Simon. Hello, Katie. And that acid-base indicator, it just changes color depending upon pH. And so I just mess around with it and see what kind of interesting effects we get. A little bit of science, a little bit of art, I guess. Right now I'm adding sodium hydroxide base. Get a little flash of the rainbow. Come on now. Already got the rainbow today. Very nice looking. And it's neutral. How do I know it's neutral? Because these are the various colors you'll see at the different pH values. And since we're at green color, that tells us we're neutral, neither acidic nor basic. I'm going to go ahead and add continue to add base here. A couple drops of base. One more drop. Oh man, that went straight to like a high pH. The camera frame rate makes the spinner at the bottom look like it's barely moving. I think you're right. Kind of cool. Yeah, you can see that violet color. We're at pH 10. We're way up there at the top. All right, I'm going to start adding acid now. I'm going to add drops of acid up here at the top. In goes one drop. It's beautiful. In goes the second drop. Whoop, there it goes. In goes a third drop. In goes a fourth drop. That was kind of like a half drop, so I'll add two. What do we like? That's like a pH of 6, maybe a pH of 5. Yeah? What do you say? We'll keep going. That's 6 drops of acid. Fluid dynamics are definitely cool, Katie. Katie, you're going to love this. I think you already know what's going to happen here, but watch what we'll do here. I'm going to go ahead and make it red, which is a very low pH. I'm going to slow the spinner down just a bit, okay? And then I'm going to start adding base to the center of the vortex, which if you know your fluid dynamics, you should know that that center of the vortex is pretty low pressure. Hello, Giannis. But you should recognize where I add base, that the color will shift to like, green, blues, and violet. So here we go. I'm going to add base, and I'm going to add it right to the center. 1, 2, 3. And you'll notice that the, of course, boy, we got a nice rainbow there, but you'll notice that the material tends to stay concentrated in the center. And that's, of course, because the center of the vortex, just like the eye of a hurricane, is low pressure, and material is going to tend to not move out of low pressure regions. What if you touch that? Will it burn your hand? Yeah, Giannis, that's why I have gloves on. If this stuff here is 20% by weight lye or 20% by weight sodium hydroxide, if I spill this on my hand, it's not like it's going to be an emergency or anything. But if I get it on there and I don't wash it off, I'll notice it later. It'll start to, burn and itch a little bit. Thank you there, Peblo. Appreciate that. Is this science or physics? It's Jordan. I don't know, man. I don't worry about definitions. It's, I don't know what it is. It's just fiddling around with acids, bases, acid-base indicators. I think you're right, Gigabean. I think you're right. Here, let me show you how this works from the start. We'll go over here. There's nothing in this particular flask over here. I'm gonna start. There's a little stir bar in there except for that, right? So there is something in here. And I'm going to go ahead and start the spinner down here at the bottom. All right, there we go. Our spinner's going. And now to this flask, I'm going to add some water. Thank you there, Giannis. All right, in goes the water. All right. Make an explosion, huh? That's not going to happen today. I apologize. But if you like explosions, you can go ahead and check out my channel, my YouTube channel, Tommy Technetium. Yes, it is distilled water, Katie. So, I do some experiments with, we'll say light explosives. Yep, that's distilled water. Okay, so now what I'm going to do to this flask, I'm going to add some universal indicator. And universal indicator is also known as rainbow indicator. I'm going to put over here, you know, these colors as I'm sort of just starting to add. These are the colors you'll see depending upon whether the solution is acidic or basic. Oh yeah, you can drink distilled water. Uranium Fever. Simon, is this a new song or something? I agree, whirlpools are definitely cool. Okay, let's go ahead and we're going to inject some universal indicator, which you will notice it's green to start, so it's neutral. Watch what happens when I add it to the distilled water, which is pretty highly purified. Come on, man, that green color turns into yellow, which is, if you'll notice, that's slightly acidic. Hello there, Maya. My day job is I am a chemistry professor, Katie. How about y'all? Drop in the chat what your day job is. No, Peblo, it is not safe to drink. One of the dyes, hello, Maya, one of the dyes contained in universal indicator is a laxative. It used to be the main ingredient in X-Lax. So, yeah, I won't be drinking this, or it might end the live in like, you know, maybe 10, 15 minutes or something like that. But yeah, hey, check it out. I added some universal indicator to water that's fairly purified, and it's like acidic, right? It's a little bit yellow in color, telling me it's acidic. So why would that be? So Katie's a medical assistant and headed to be a physician assistant. Oh, I wish you were my student. Love to have you. The song Uranium Fever came out in the 1950s. Oh, I'll have to check that out. Uranium Fever. Okay, anyway, this is slightly acidic because any water that's been exposed, thank you there, Joshua, any water that's been exposed to the atmosphere is going to have carbon dioxide dissolved in it. And anytime carbon dioxide gets into water, it's going to be slightly acidic. Okay, so now I'm going to add some drops of hydrochloric acid. What happens if you drink a water with acid-free 3? I'm gonna add a few drops. Peblo, I could touch this and it wouldn't be bothersome. So you drink, so to speak, water, Giannis, with an acid level of pH 3 all the time. So anytime you drink, for example, orange juice, you're going to be drinking a fluid that has a pH of around 3. Vinegar is like pH 2. So we eat acids all the time, and they run throughout our body. Like ascorbic acid. Ascorbic acid is better known as vitamin C. So we need acids to survive. Okay, I'm going to start adding drops of base to this. So then goes 1 drop. Look at that, man. That's a huge shift. Man, that was a gigantuous shift. We went from pH 3 to pH 10 with 1 drop of base. What gas makes a water more basic? That's an interesting question. Ammonia, if you dissolve ammonia gas into water, it's going to become more basic. We are getting some interesting colors here. Yeah, Peblo, it is dark. That's because I've put quite a bit of universal indicator in here. Okay, now we're going to start adding some drops of acid. Here we go, 1 drop there. Boy, that's really shifting heavy. Drop of acid now, hydrochloric acid. What would happen if I dilate a neutral solution if its pH already 7? Asks Terminator. Hey, big boy, quit spamming the comments or you get blocked, all right? Please don't spam the comments. I'll block you pretty quick. I'll give you 1 warning. In goes a drop of base. Hey, how you doing there, IG? Welcome. Welcome. We'll go over here to, let's do this one over here because the pH is changing really rapidly on this one. Let's go over here to this one. Here we go. Put a drop of base in here. See what happens. A little bit of flow pattern going on. I want to see if I can get the light just a bit better. Just a bit. It's going pretty good, IG. Thank you there, Simon. I think it's looking pretty cool, too. It's just kind of fun, you know? What's the name of the pH detector, asks Cassidy. The name of the pH detector is called Universal Indicator. It's actually a mixture of 4 dyes. Do any of these burn, or are they just called acid like citric acid? Pablo, I'm not 100% sure what your question is, but yeah, there are many acids that burn. What if we mixed them? Let's find out, Katie. What happens if you drink one with a number 10? Giannis, most of us, big boy, you are gone. Come on, man. Take your racist bullshit elsewhere. Jeez, oh, Pete, people. Come on, man. What is wrong with people? Gosh almighty. Sorry for my swearing there, but that's just wrong. Hey there, Bass Bucket. Hey there, Ozzy. How are you? Nope, he will not be missed, or they will not be missed, I should say. That's just ridiculous. You're asking if these burn. So I think you're asking if these burn. These, yeah, I mean, these will burn your skin. So 20% by weight sodium hydroxide will burn your skin. I'm not going to repeat it, Gigabean. And the 20% by weight hydrochloric acid will also burn your skin. Hello there, Jim Bros. What's going on? Somebody asked, let's mix them. So what I'm going to do is I'm going to try to get this one over here at a pretty low pH. And then we've got this one over here at a pretty high pH, and we're going to mix them. Yeah, that's right, Pablo. The higher the concentration of the acid or base, the more it's going to burn you. Yep, Terminator, you got it. Well, we're just doing some experiments there, Jim Bros, as usual. Okay. Oh, I got to find a mixing flask. Hold on a sec here, folks. I got to find a mixing flask. Here we go. I got one. Looks like I got one. And let's give it a shot. Hey, and it looks like we got over 100 people on here. So because of that, we're going to do a different experiment here after I do this one. I got another experiment planned for us. Hello there, GH. All right, Castle-y, here we go. You should add lemon just because why not? You're right, Base Bucket. I should. Unfortunately, I don't have any with me. All right, here we go. A little bit of both. A little bit of red, a little bit of violet. Put it in the same container. A little bit of red, a little bit of violet. Let's squirt them in the same container. Looks like my acid is just a little bit more concentrated, so I'm going to just squirt a few more squirts of base. Just a few more. Actually, what I'll do, I want to make this just a bit more basic. One. Yeah, let's do that. Let's see how that works. Here we go. All right, let's get back to mixing these. See if this works. Yeah, we still got a bit more acid. Looks like my acid is much more concentrated. The red flask, the acid in the red flask is much more concentrated than the base. There we go. I think we're getting there. So I mixed a bit of the violet and a bit of the red. Actually, a lot more of the violet and a bit of the red. And look what we get. We get yellow. And that makes sense. That makes sense to me. And the reason why it makes sense is because if you mix acids and bases together, you neutralize each other. So, you know, we have an acid over here at pH 3. We have a base over here at pH 10. And when you bring them together, they neutralize each other. So they both come closer to pH 7. It looks like we ended up with pH 6. And that's because this is a bit more acidic than this is basic over here. I'm going to try to balance this just right. Let's see if we can just add just a bit more base over here to the left. Excuse me, to the right. See if we can get this going good. All right, we'll pour that back in there. Pour this back in here. And let's see what happens if we mix them again. What do the negatives mean? I apologize. I don't understand the question, Peblu. If you're asking that like this, that doesn't mean -5. This means 425. But that may not be what you're asking, Peblo, so I apologize. I don't quite understand. Here we go. Let's try mixing them again. A little bit of violet, a little bit of red. Looks like the red is still a bit more acidic. I can tell that because when you mix them together, we're still getting quite a bit of red color. So 2 more squirts of the violet. And you'll notice, I'm just trying to get like a green color is all I'm trying to do. Sure enough, they neutralize each other, right? Green means neutral. This isn't quite green. It's like a yellow green, but you get the idea. Is there a way to remove the smell of vinegar without changing its chemical structure? That would help a lot. How do you get, well, what I would do to try to remove, to remove the smell of vinegar without changing its chemical structure, that I don't know how to do. So Simon was just testing out their cassette tape recorder that they got off Amazon. What do I think about drinking alkaline water? It seems silly because the body wants things balanced. Katie, you're absolutely right. Your pH of your blood is buffered. It is buffered to remain at pH, somewhere between pH. I'm going to add acid over here on the left, by the way. It's maintained somewhere between pH 7.35 and 7.45. You go outside of that and you're going to end up in the hospital. So these ideas that you want to kind of change your pH of your body it's just a waste of money, man. It's just absolutely a waste of money. I think more violet would make it greener, says Pablo, and they were absolutely correct. Here we go. What am I adding? Oh, I'm adding sodium hydroxide. Let's add sodium hydroxide over here on the right. Hey, thanks, Ian. I appreciate it. Let's do that. We got over 100 people on here. So what do you got in school tomorrow, Jim Bros? So we're going to go ahead and do a separate experiment here pretty quickly. If you haven't seen it before, you're going to like it. An oxygenated water, wouldn't that make peroxide? In a sense, yes, Katie. So yeah, water's H2O, man. And if you change, water so it has an extra oxygen in it, then you're going to have H2O2, which is a completely different compound. What do I think about uranium chemistry? I think the only uranium chemistry I'm aware of is uranium hexafluoride. Cody's lab does indeed do some cool experiments. I agree, Gigabean. Here, let's try this experiment. Let's do this one here. I have a green liquid in this bottle. Green liquid in the bottle. Not going to happen there, Pen. Okay, green liquid in this bottle. And to this green liquid, I am going to add some sodium carbonate. It's just a white solid, all right? Does the yellow in the smaller cup have a higher HC? I don't know what you mean by HC, Pablo. I apologize, so I can't answer the question. Nope, not going to happen there, Pen. But I do that in a safe manner in a hood. And if you want to check that out, you can check out some of my short form videos that I have on my YouTube channel. But I'm not going to do that in an unsafe manner. Okay, here we go. We got this green fluid, and to that green fluid, I'm going to add a white solid, and we're going to watch what happens. So here we go. Put this little funnel up here. I'm going to pour this in through the funnel. You can see it being added up at their top, and it goes, in goes the solid. All right, let's mix that baby up, and let's see what happens, okay? So I had that green liquid, and we'll mix it up and hope, who knows what'll happen, huh? Here we go. Oh, I see, HC. Yeah, you can call it HCl. Sorry. So part of the formula got rinsed off the bottle. I'm going to try to mix this so that that white solid, you can see it's not quite all dissolved. I want to try to get it so it's all dissolved. Here's a true fact about someone surviving something impossible. Back on the day before Memorial Day 2023, they had a seizure and managed to survive it. Holy cow, Simon. Hopefully someone was around for you. This is not slush, SC Zol. This is a green fluid to which I added a white solid called sodium carbonate. And while I'm mixing it up, I'm going to just go ahead and tell you the fluid was actually a mixture of water, isopropyl alcohol, and some green food dye. I think that might work. Let's see. So I don't think all of the solid is dissolved, but this still may work. Let's see what happens. Hey, it's working, baby. Come on, baby. I bet that did scare them, Simon. The chemist has entered the chat. I am salting out a mixture of water and isopropyl alcohol that has green dye added to it. This Forbidden Mountain Dew, the live ends in about 15 minutes because it contains a laxative. So there you go. Isn't that cool? So the green changed to a yellow and a blue. How did that happen? How did that happen? Not going to happen, Pen. Okay, so let me show you how this happens. I agree, one chemist. I definitely agree. Yeah, the blue looked better. Let me show you how I did it this time. It looks like magic, but it's not. So here's how you do this trick. Here's how you do this trick. I've got this bottle here. Yeah. And if you look carefully, you can see like there's two layers. Like look right here as I fiddle this around. Yeah, you can kind of see that, see there? There's something funky going on there. And that's because to this flask, I added both water and some isopropyl alcohol, okay? So what I'm going to do is I'm going to mix it up. So now you know I've mixed. You can see, ooh, there's some interesting mixing going on there in there. Very interesting mixing. There's two different fluids in here. One of the fluids is water, and the other fluid is isopropyl alcohol, okay? So I've mixed them together. All right. Let's give it a good shake. Okay, and let's watch that happen. And now what I'm going to do to this, remember, there's two fluids in here that are well mixed. There's water and there's isopropyl alcohol. Now what I'm going to do to this flask, or this bottle, I should say, I'm going to add 1 drop of yellow food dye, and it goes. 1 drop of yellow. It looks kind of cloudy because there's a bunch of bubbles in there. And then I'm going to add 1 drop of blue food dye. So here we go. In goes the blue. Okay, so we've got both dyes added. Again, remember, there's 2 different liquids in here. There's water and there's isopropyl alcohol. And to that water and that isopropyl alcohol, I've added blue dye and I've added yellow dye. Looks beautiful, doesn't it? The way those things mix, absolutely gorgeous. Just a really pretty experiment. Hey, thanks for all the likes. I appreciate those. Now what I'm going to do is, I'm going to mix these up. Okay, so let's mix them up. And that's going to, of course, since everything is well mixed, this is going to give us a green colored solution, as we would expect. Everything is well mixed. So the water, the alcohol, the blue dye, and the green dye, all 4 of those components are very well mixed, okay? Okay, now, to this flask, I'm now going to add some sodium carbonate. If I can find it. Where the heck did I put my sodium carbonate? Here it is. Oh, here we go. Here we go. Okay. Sorry, I had to remove somebody. All right, here we go. So remember, just to remember what's going on here, we've got water in here, we've got isopropyl alcohol in here, and we've got blue dye and we've got green dye, okay? Blue dye, yellow dye, water and alcohol. Okay, here we go. Up at the top, you can see up here the funnel I've got. I'm going to add this white solid, which is sodium carbonate, and it goes. So again, I'm adding a white solid, a salt, a particular salt, to a mixture of water, alcohol, blue dye, and yellow dye. Here we go. I'm going to mix this up. Epistemology. Someone entered the chat with a name that, in my opinion, was racist, and because this is my channel, I make the rules. I blocked him. I don't play with that. So, you know, if that bothers you, you know, you're certainly welcome to find another channel. Here we go. Here we go. I am mixing this up. Mixing it up. So what's going on now when I mix the salt with the mixture of alcohol and water? It turns out that the salt and the water mix so well and they are so attracted to each other that the alcohol cannot compete, and the alcohol gets pushed out. The alcohol gets pushed into the top. So again, this was a mixture of water and alcohol. It's a mixture of water and alcohol. I added to this a white salt. The white salt mixes very well with the water, extremely well. Uh-oh, do I quit? I might have to add a little more. No, I think it's going to work. And because the salt and the water mix together so well, it pushes the alcohol out. Now, you're going to be able to see it because of the two dyes that I added. The yellow dye dissolves better in the water, and the blue dye dissolves better in the alcohol layer. And so as this separates, we should be able to see that happen. Cemetery boy, baby, sorry, how come the yellow decides to go with the alcohol and the water decides to go with the blue food coloring? I apologize, I probably said it backwards. The yellow goes with the water. I apologize, I probably said it backwards. And the blue goes with the alcohol. That has to do with the fact that the dyes are attracted to those molecules through a number of means. We'll just talk about one of them. One of them is called hydrogen bonding. And things that are going to hydrogen bond better are going to end up in the water layer. And it turns out that the yellow dye has more ability to hydrogen bond with water than the blue dye does. And that's why the blue dye ends up getting salted out. I think I'm going to have to add just a bit more salt to get this to actually work. I'm just a little short, so bear with me. I think my separation is not quite complete, so let's add a little bit more salt here. Just a bit. It also has to do with the sizes of the molecules. The larger the size of the molecule, the tougher it is for it to dissolve in water. Because if you're a larger dye molecule, you have to push apart more water molecules, which is very energetically costly to do that. All right, let's see if this gets it. Sometimes, there we go. Come on, baby. Let's see if I can get the good separation. So once again, there was a mixture of water and alcohol in here. To that mixture of water and alcohol, I added some dyes, and I added a white solid. That white solid dissolves so well in the water, and there's such a strong attraction that the water and the salt will come together and push the alcohol out. And it turns out the yellow dye dissolves better in the saltwater layer, and the blue dye dissolves better in the alcohol layer. We're seeing it good now. Do I have vegetable oil? I wonder what happens if you put Alka-Seltzer tablet into vegetable oil. That might be fun. Yeah, I think that worked pretty well. I think the ratio I had a little bit too much alcohol in this one, but certainly you can see the effect. So you guys want to do some, sounds like you guys want to do some vegetable oil, and that's kind of messy, but I guess we could try it. Hovig, any kind of dye works fine. Is there a special dye? Is it regular home salt? So Hovig, you can do this with regular home salt. If you're going to use regular home salt, I would suggest you use 91% isopropyl alcohol, not 70% as I've used here. And the dyes, oh man, with the regular home salt, if you can get blue and red together, I think that works. But you have to experiment. I can't really remember. Okay. So folks want to try vegetable oil in an Alka-Seltzer tablet with a little bit of water is what I'm hearing. So let me get that set up. Let me see if I can get that set up, okay? We'll try it just to goof around. All right, hold on a sec. Let me get a little flask, and we'll try this. All right, what size flask am I going to use? I'm going to use a small one because I don't want to make a huge mess. We're going to use a smaller flask. I got my vegetable oil. Where's my vegetable oil? That's my glue. Here's my vegetable oil. I got my water. Okay, here we go. If you guys want to try it, we'll try it. Little smaller flask. Yes, it would work with ethanol. Ethanol will work. Your best salt, the salt that I find that works best in this experiment is going to be potassium carbonate. I just use sodium carbonate in this experiment, but you know, potassium carbonate is going to work fine. Okay. So there is a little bit of water. Let's add some oil. No, because SC-Zol, the blue dye was just blue food dye. Then goes some oil. That looks pretty, doesn't it? Huh? Doesn't that look pretty? Come on, man. That's just beautiful. What the heck? Haha, that's pretty. A little bit more, baby. I hope this doesn't make too much of a mess. Doesn't that look nice? All right. Let me just lower this just a bit. I want to get the angle right. Yeah, I think that looks nice. It does look satisfying, doesn't it? I'm going to add a couple drops of dye. Yeah, let's just do it. After this, you can do one of those experiments. You put honey and water and vegetable oil in the same cup. And you see which things have different weight. I'm not sure. I'm going to put a little drop of blue here. Boop. There it goes up there at the top. Down it goes. Wonder if it's going to explode and go into the water. It does, Giga Bean. All right, let's put a little drop of yellow in there. Let's do like, I don't know, 3 drops. Oh, look at those going down. Those are bigger. That's interesting. All right, 2 more drops of blue, maybe. 1 over here. 1 over here. Down they go. Let's just do 1 more each, huh? 1 right in the middle, blue. And, oh, look at that, baby. Come on, that's beautiful. That was beautiful. It just kind of popped and went. All right. See if the other 2 pop. All right, now we got to do the Alka-Seltzer. All right. I'm not going to do the whole thing. Well, we do like a quarter of the piece first, shall we? Just to see. All right, here we go. In goes the Alka-Seltzer tablet. Up there, down it goes, and let the magic begin, baby. Oh, it's beautiful. It is beautiful. And it's like gone. It didn't last. It's up here at the top. Well, that was a bust. Here, let's throw a big one in. Get in there. Come on, man. People want to see a show. I think there's too much dye. What do y'all think? A little too much dye. It's pretty. Thank you there, Simon. Yeah, it's a little bit like a lava lamp, I guess. I mean, people like this thing. I don't know. It's kind of fun, I guess. Get down in there, man. Get down in there. Wouldn't it look cool without adding dyes as well? Let's find out, Ozzy boy. Let's do it. Come on, man. We're going to do one without adding dyes. I bet you're right. I bet that would look prettier because the dyes are obscuring everything, isn't it? It does look like a mess. It's like, what a bust. Here, okay, I got another Alka-Seltzer tablet. We can do this again. Give me a second. New Alka-Seltzer tablet. We'll get us another flask. A little bit more oil. I got my water. We're in good shape. My water's also kind of hot, so the reaction's going to go pretty quickly. Let me add cooler water this time. All right, so we're going to add cooler water this time. Where's my water? Yeah, this will be colder. This won't go as quick. What if I put a whirlpool in it? We'll try that next, okay? We'll try. Let's just let it ride slow here for a bit. Okay, there's our water. Is that how much I did last time? No, I did a little more. Okay. So there's my water. All right, now let's add some. Yeah, funny games. This isn't the water I drank. It's some distilled water. In goes the oil. And that's just beautiful, just the heck. Look at that. I mean, what the heck? Like, nature just does the coolest stuff if you just, like, watch and pay attention. Just gorgeous. It's like a big old blob in there, man. Come on, nature, do your thing. Look at that beautifulness. Okay. Okay, here we go. In goes a drop of, not a drop, curses. Where'd I put it? Here it is. All right. You want to do, thank you there, Daniel. You guys want to do an entire Alka-Seltzer tablet, a half an Alka-Seltzer tablet, or a quarter? Let me know your thoughts. Let me know your thoughts. Am I going to break it in half? Am I going to break it in quarters? Or are we going to put the whole thing in? You let me know. Ozzy says half. Katie says the whole thing. Gilded says the whole thing. Administrator says the whole thing. Gigabean says the whole thing. Administrator says the whole. All right, we're putting the whole thing in, folks. Here we go. Here. Okay, I think whole has it. Here we go. Up here at the top. Into the oil. It's interesting. It doesn't notice it. Oh, actually, it does. Look. You can see a little bit of gas forming. You see it? So a little bit of it does react with the oil. I wonder if that's oil or residual water. Anyways, let's just drop it in and watch it go. Oh, yeah, that's pretty. That's cool because you can see it with much better without the dyes. You got it, SC Zul. You got it, Fidro. Vinny, you got it. The whole thing. Could be contamination of the water, Katie, I agree. It's pretty, man. Look, it's just beautiful. How you doing there, Dobres? Or Dobbs, sorry, I'm murdering your name. I apologize. It does look cool, Administrator. I agree. It's beautiful. Very, very pretty. And it's still going, man. It is still going. Can I do a dehydration reaction? I can if I want, Mussin. I dropped in an Alka-Seltzer tablet, Diane. Dropped some phenolphthalein. I apologize, Dawasish. I do not have phenolphthalein. I do have universal indicator. I think we're done, huh? I think it's all done. Let's pop another one in there, huh? I got another one. Let's pop it in there, see what happens. Mosin, if you want to see that, check out my channel. I do lithium, sodium, potassium. I drop all those into water. We study those. I just do that in a safe environment. I'm not going to do that downstairs in my basement. Here we go. We're going to put in another one. Casserly, I won't be doing that experiment. I don't mess with radioactivity. In goes another Alka-Seltzer tablet. 3 at once. Rubidium. So, Administrator, I did put a rubidium in water. I've done that experiment twice. Both times it broke the beaker. And one time it actually burnt my desk. What happened if the suspension, if the lid was added to the glass and the CO2 wasn't allowed to escape, just a minor pressure? Well, I imagine it would just push the lid off. If it was enough pressure, I guess it could break the glass. I'm from the United States, Nasir. Okay, you guys are going to like this experiment. Don't tell anybody. Well, I don't know if I should let you know I've been doing this because I don't want to let the secret out. I don't want to get scooped. Some of the experiments I've got ready to come out on my channel, so maybe I'm not going to do that one. Is there a way to create liquid carbon dioxide? There is, the Administrator. You just have to be very careful. What you do is you place dry ice in a sealed flask. The issue there is that as the pressure builds up, of course, the flask can explode. But if you do it in a flask that won't explode, once the pressure exceeds a certain point, the CO2 will liquefy. Can I do Coke oil and Mentos? Katie, I have done that. Check out my channel. I have a long form video where I do just that. I do Coke oil and Mentos. The best reaction I have ever done. Now, Sarah, why don't you tell me your favorite reaction you've ever done? For me, wow. I just kind of say whichever one I'm doing at the time. Administrator, be very careful. Be very careful if you try that because, you're building up a lot of pressure inside a sealed flask. That's a bomb, right? So you got to be careful with that. Silly goober, your CO2 just goes supercritical. How do you stop that? I don't know, man. What's my least favorite chemical reaction? I don't know, man. Most dangerous experiment I've ever done. Probably the bucket launch. So you can check out the bucket launch on my channel. It's a remarkable experiment. It's fascinating. Check it out on Tommy Technetium. Check out the bucket launch. You will not be disappointed. I like Devil's toothpaste, huh? Do they just sell highly reactive chemicals, or you have to have a license? Depends. Depends how clever you are. Let's just put it that way. Okay, let's go back to our color changes, huh? Oh, so the Marie Curie experiment is to have bubble of oil floating in the middle of water, alcohol, and ethanol. It's supposed to be one of the experiments she did in front of her students. A bubble of oil floating in the middle of alcohol and water. So is oil more dense than alcohol? Sorry, I got to put somebody in timeout. Man. Oh, gosh. Yeah, we got some more crap on. Sorry about that. I had to block somebody. Okay, here we go. I'm adding acid over here to the flask on the right, and that's dropping the pH. How can I just do dangerous reactions on YouTube? I don't give away all the information on how to do it. It's that simple. You just talk about the reaction, and, it's like watching people race cars. That drive cars around a track at 200 miles an hour. That's dangerous, If people don't have access to a track and a race car, they can't do it. And people don't have access to the chemicals or the knowledge on how to do it. So that's why I feel like you can put this stuff on YouTube for educational purposes. Oh, Fred, so this is what's going on, Fred. So here we go. In this flask here, I have a mixture of chemicals known as universal indicator. Universal indicator changes color depending upon pH, which is just how acidic or basic something is. So, in this particular flask, the universal indicator will show these colors at different pH values. So most of the flask here, once it sort of homogenizes, you'll see it's violet, which means we're at pH 10, which is very basic. I'm now going to start adding acid to the flask, which is going to lower the pH, and you'll watch the color shift accordingly. Dewashis, I am not a synthetic chemist, so I'm not going to be able to answer synthetic chemistry questions. Administrator asks, what is universal indicator made of? Yes, that is a magnetic tablet at the bottom. So here we go. Let me add a few more drops of acid here. So universal indicator is made of these different dyes. One of them is called thymol blue. Another one's called methyl red. Another one's called bromothymol blue. And the last one's called phenolphthalein. These are the different colors that each of these dyes display at different pH values. So you can see thymol blue is kind of the heart of universal indicator. We get a lot of the rainbow colors out of thymol blue, but if we just use thymol blue, all we would see is red, yellow, maybe a light blue, and a blue. But we want to see all the colors of the rainbow. So what you do is you add all these other colors, dyes in, which is like adding other colors. And then, at pH 3, you have a red colored dye, a red colored dye, slightly yellow colored dye, and a colorless dye. Altogether, that looks red. And that's just the way it works. So, at pH 4, this red shifts to yellow. Everything else stays the way it is, which is going to shift you from a red to a orangish color, and so forth. How quickly would the color shift from basic to red if I added piranha mixture? Very quickly. But so this is, this stuff here is about 1/5 as concentrated as the acid and piranha mixture. So long, Simon. Thanks for hanging out. I wouldn't drink it there, Fire. I mean, I suppose you can if you want to, but there's a laxative. One of the dyes is a laxative, and I think that might ruin your afternoon. So there you go. I think we're going to do the, let's do the, roughly speaking, I'm doing a little bit of math in my head. It may be as low as 1/10, but all right, here we go. Let's put this on here. So SC Zol asks, as I'm adding base, isn't the volume going to rise? It is, but just recall that I am only adding drops of this, and each drop of this has a volume of about 1/20th of a milliliter. Phenolphthalein is pretty cost effective. Dyson, what makes an aurora borealis's color? So that's going to be high energy particles from the sun interacts with molecules and atoms in our upper atmosphere, and it excites them, gives them energy, and those molecules give that energy back off as light. The color of light is going to be based on the specific atom or molecule that gains the energy. All right, so what I'm going to do now is we're going to get both of these at like a pH. Let's go both pH of like 3 or so. So I'm going to add a bunch of acid to each flask. Get it nice and red. Nice and red. Okay, this one over here, we're going to keep spinning, and this one I'm going to turn the spinner off. All right. Now, the one that's still spinning, I'm going to add 1, 2, 3 drops of base, and we're going to add 3 drops of base over here. And let's watch what happens. Got the rainbow over there on the right, which is kind of cool. I'm going to add a 4th drop just for the heck of it, see if we can get the rainbow again. It's really pretty when we get the rainbow. Ha, thanks, our administrator. Over here, of course, the reaction is much slower. The mixing is much slower. I wonder what's going to happen over here on this side. I don't know. Let's find out. Let's find out. Man, you guys, I'm making a mess. I got all this extra gunk around here from all the suggested experiments. I'm going to try to tilt this just a bit so we can get a little bit more light over here on this side. All right. Really pretty. Kush, can I make some of that? I'm not going to mess with that. How would I dispose of dry ice? I just throw it outside on the ground. All right, let's add a little bit more base over here. I mean, you can see when it's spinning, you know, the colors homogenize quite quickly. Over here, what's kind of interesting about the one on the left, this is kind of cool when this happens. You see red and violet in the same flask. And what's interesting, it's funny, Chris. And what's interesting is when you see red and violet in the same flask, you see a difference in pH of 7. You're like, well, so what? So the pH difference is 7. Well, the pH scale runs on powers of 10. And because of that, the difference in acidity between pH 3 and pH 10 is a difference in 10 times 10, 7 times. What's 10 times 10, 7 times? So that's 10, 100, 1,000, 100,000. What did I do? 10, 100, 1,000, 100,000, million, 10 million, 100 million. So there's a difference in acidity between actually it's 10 million, a difference in acidity between these two of 10 million times. So when you see the violet and the red together, that's a difference in acidity of 10 million times acid concentration. Where does the 7 come from? The 7 comes from the fact that when you have pure water or you have water with a neutral solution like we do over here, the concentration of acid and base are both 10 to the minus 7. That's where that's actually where it comes from. Yeah. Oh, look at that over there. We are really getting some beautiful patterns over here. They're a little psychedelic, man. Isn't that cool, Kelly? Very cool. Yep. And what's nice, you know, you can sort of see the greens and the yellows kind of mixing in. And that makes sense, of course, because when you have I'm going to add another drop of base over here. I think we need a little bit more blue. One more drop of base in there just to get it going. And when you see the greens and the yellows, that makes sense because the red and the violet are neutralizing each other. So you're going to see more neutral colors. Very cool. Over here, man, look at that over there. We got like a pH of 10. Let's add some acid to this, get it going back down. It would look cool on a shirt, Fred. Man, I wish I could capture that. I wish I could, like, I don't know how to do it, but it'd be neat. That is gorgeous. Boy, is that really pretty over there. Just chase it with a bit of acid. We're running low on acids. I'm going to just put a little drop of acid in here, get a little redness going in, huh? A little bit. Very pretty. All right. A little bit of acid over here. Hydrochloric acid, same acid that's found in your stomach. That base sinking mid-glass so quickly has to do with density. I think that's correct. So, Kelly, this is usually what I see in this experiment. I do tend to see the base end up at the bottom and the acid end up at the top, which indeed tells me, like it does you, that I think my solution of base is more dense than the acid that I use. So that's kind of nice. It gives us a nice little effect. I'm going to add 2 more drops of acid over here. Give us a little more red in here. 1, 2. Let's see what happens. It's gorgeous. And while we're letting that develop, I'm going to go ahead and put a few drops of base in here. Let's see if we can catch the rainbow. Come on, baby. Give me a rainbow. I think we got it. We got the dynamic rainbow on the right and a more static rainbow on the left. That was cool. Administrator asked, Tommy, how hard would I say it is to get a university degree in chemistry? Well, it depends on a number of things. I mean, it's gonna depend on your aptitude for remaining focused on your goals, and being able to put in the time of study that you need to learn the material. It's just like anything else, man. If you love it, it's a joy to learn. So yeah, was it hard for me? I'm going to say no. I mean, I just loved it, man. I ate that stuff up. Kelly, I want to be clear here. It's not the case that base is always denser than acid. It just turns out that this particular solution of base is more dense than this particular solution of acid. The density of water-based solutions is going to depend on how much solid is dissolved in the water, more so than whether it's acid or base. Yeah, I missed it, Katie, but I'm glad you saw something cool there. All right, we're getting near the point where I'm burning out. So what I do near the end, just so you know, is I flip the camera around and I talk to folks. So you see my ugly mug, just beware, it's coming. I'm guessing in the next 5 minutes or so. So it's getting time for me to stop staring at a screen. So basically you have base plus acid is a reaction, but base plus base is no reaction, and acid plus acid is no reaction. In terms of acid-base chemistry, that's correct. What we say is acids and bases react with each other, and when they react with each other, they neutralize each other. The acid neutralizes the basic properties of the base, and simultaneously, the base neutralizes the acidic properties of the acid. Now, you can have some compounds that are both bases that will react with one another. It just won't be an acid-base reaction. Ozzy, man, I've been doing this for like 53 minutes. You're going to have to forgive me. I'm an old man. I can only handle this for so long. I don't have the endurance I used to. What can I do with my degree? What are the job prospects for a chemist, if that's the right term? Yeah, oh boy, what are the job prospects for a chemist? So I've been teaching chemistry for quite some time. And my chemistry majors have gone on to do a wide variety of things. They've gone on to teach. They've gone on to be doctors. They've gone on to be lawyers. They've gone on to be physician's assistants. They've gone on to be nurses. I've had some gone on to be, holy cow, I've had some gone on to be like religious leaders. Yeah, I mean, there's a wide variety of things. You know, some of them work in a lab. Some of them work in the pharmaceutical industry, trying to find new treatments for various diseases, or just one step. So like when chemists make drugs that are intended to help people with various diseases, there are sometimes like multitude of steps, of chemical steps that have to happen for you to get to your end product that you want to get, and that's going to be used as a medication. And some people will just be very good at 1 or 2 steps in a 10-step process. So there's a whole bunch of things you can do with a chem degree. I want the dynamic rainbows to be a foam wallpaper. Me too, man. Can you do a laser experiment tomorrow with fractures of light? That might be interesting to try sometime, Fidro. Laser experiment. I like that. I have to think of a way to do it in a way that would, that keep people's attention. How good is a chemistry degree in terms of employment potential? Are there a lot of unemployed people with chemistry degrees? 6 stacks. So if you want to get a job and you've got a chemistry degree and you did fairly well and you're serious about getting a job, you're going to get one. You can't it's like anything, man. You can't get your degree and then put out 3 applications and expect to get a job. When I got a chemistry degree, and after look at that over there, that's pretty. And after I got my degree, I put out 100 applications, and I got 4 interviews. And of those 4 interviews, I got 4 jobs, 4 job offers. So, you can make it interesting by using the prism things where you shine a white light and mix a rainbow. And cool, man. Hey, Fedro, did you see my experiment on the rainbow chocolate? That was a lot of fun, man. A lot of fun. The rainbow chocolate experiment was, and in a sense, my next video I have coming out, y'all be looking for it next weekend. This weekend I put out a video that I did with some of my students. We made like a propane shooter. It was kind of fun. But next week I've got a video coming out where there's this beautiful chemical reaction, man, and it gives off, in a sense, it gives off laser light. I mean, I'm speaking colorfully here, but it gives off like monochromatic light of a single color, which is very similar to laser light. So it's kind of neat. Look at that. A propane shooter, administrator. That's what we made. Look at that. That's pretty. Okay. It's not that dangerous. It's really not. All right. It's getting near time to turn the camera around. What happens at an atomic level when there is an interaction between acids and bases when they balance out? Kelly, here's what happens. One way we think of acids and bases is we think about acids donate a chemical species that we call a proton or an H+ ion, okay? So acids are this is just one way to think about them, and it's the most common way to think about it. Acids are molecules that contain H+ ions, and they're good at donating them, so they give them away. And it happens that a base is going to be a substance that accepts protons. So acids are proton donors. That's what's happening on the molecular ion level. And bases are proton acceptors. So in this experiment, so to speak, my right hand is an acid and my left hand is the base. Can I add red to the green? Sure, Samurai. Let's do it. So long, 6 stacks. Yeah, you can think of it that way, administrator. Here we go. We're going to add a little bit of the red to the green. Here we go. I don't think it's going to be acidic enough. Yeah, it's just the concentration is way too low for there to be any impact. So you guys should know that this acid that I'm adding here is really concentrated so that we can get an effect. In other words, this acid here donates a lot of these. So the difference between acids and bases are actually bound in electrical charge at its core at the atomic level. Let me think about this. You can think of it that way, I guess. Yeah, acids are proton donors, H+ donors, and bases are H+ acceptors. All right, let's mix this over here. I'm going to mix this up. Let's see what we get. Does the acid or the base win? It looks like the base does. The acid I'm using, how dangerous is it? It's about 100 to 1,000 times more concentrated than stomach acid, which is why I'm wearing gloves. What's the strongest acid I have ever given to the green? Probably sulfuric acid. Will the magnetic spinner, what a great question. Will the magnetic spinner keep spinning if I raise the glass a bit? Let's find out. That's a new question. Let's find out. Here we go. We're going to raise up the glass off of the, how high up can we go? It's still fighting. Oh, there, it's out of, it knocked out. I'm going to say about 2-3 centimeters above the flask, or above the spinner. Oh, nice, Katie. All right, let's flip this around. Let's talk a little bit. Let's get the light on in here. Oh. Oh. Yeah, I'm a chemist. Hello, administrator. Hello, folks. I got these on for my, they got readers in them. So they got little readers in there so I can tell what the heck you all are saying. I need my reading glasses. Oh, nice, administrator. What happens if I put the spinner on it without a beaker? Let's do it. Let's just do it. Put the spinner on without a beaker. Where's a little... All right. What happens if you put... Oh, okay. Hold on. Here's a big spinner. We'll stick it on there. We'll flip the camera back around. I look like this. That's hilarious. No, I didn't do that. In my younger years, I was an athlete. All right, there we go. There's a stir bar. Turn that baby on. There we go. Do I think chemical sales is a good profession in 2025? I apologize, Easy. I do not know. There you go, folks. All right, we'll turn that off. Nice suggestion. Nice suggestion. What else we got out there, folks? What's the max RPM? I think it's 3,000 revolutions per minute. I think that's right. Dark Horse, I don't do any black hole research. Electric induction. We got the electrical engineer in the house with Ozzy. Nope, Samurai never has exploded. People tell me that a lot, Palad, Mr. Palad. They do, administrator. Check out my YouTube channel. I do some experiments with alkali metals and water. You can check it out. I do mostly YouTube shorts. Tommy Technetium. Check out my shorts. I do a lot of videos with, those kinds of things in, alkali metals and water. Idea for an experiment, the tornado experiment. You buy those tornado fan things and you can put cool items inside like the tornado and see which will rise up in the... Interesting. I'm not 100% sure what you mean by a tornado fan. Can you give me a shout out? Hello there, Robert. Thank you there, administrator. I appreciate it. Aren't there some substances you don't want to use water to get off? And yeah. Ozzy, I do it all by myself. I do it all by myself. Now, I will tell you this. I have two sons that are like film majors. And I don't want to say I very often will send them my videos and ask them if they have any suggestions. And man, I'm telling you what, those guys know what they're doing. You know, they'll give me a few suggestions here or there. Not always. Sometimes, they're busy. They don't want to look at it. But other times they'll say, hey, Dad, try this or try that. And I learn a lot from those guys. Thanks there, Sebastian. Thanks, Sebastian. I appreciate it. I hope to see you again. A smoke fan with dry ice in it. I'll have to try that. I do, Katie. I have both just a regular cell phone that I can use, but I also have a Phantom high-speed camera. Hey, thanks, sir, Kelly. Appreciate it. Hey, you know what? Sounds like my wife is home. She's been working all day, and I want to see her. Thanks, Ozzy. I appreciate that. I appreciate the subscription. Very much. Thank you. Thank you very much. Hey, I'm going to take off. My wife's home. I want to hang out with her. I haven't seen her all day. And I just want to thank you for joining in today. I wish I had some liquid helium. Thank you for joining in today and, checking out some of the beauty of this universe. Man, I mean, we just stuck oil in water at one point and it was cool. And I think that's, if you just kind of pay attention to the ordinary, man, there's so much beauty in the ordinary if you just take time to pay attention. So thanks for paying attention to the ordinary with me in a special way today and seeing some of the beauty there. And I usually do these live streams on Fridays or Saturdays or Sundays. I usually do it once a weekend whenever I get the chance. Usually once a week, and it's on the weekend. So thanks for hanging out with me. And, I hope to see you around next time. Consider a subscription. Tommy Technetium. But if not, that's okay too. And thanks for hanging out. We'll see you next time. So long, folks.